Hi, everyone. Just wanted to go over chapter 21, the beginning part of that with you guys today. We are, as I said in the assignment yesterday, we have two chapters left we're going to try and accomplish this year. Chapter 21, chapter 22 on magnetism and electricity, so we're going to have to move pretty quickly to get through them. We're going to put that little section 5.1 that we did on work, we're going to kind of combine that with chapter 21 here so we can get everything you guys need to be able to move on to physical, or I'm sorry, move on to biology for next year. So to get us started here, the first thing I want to go over with you is static electricity. How is static electricity formed? Static electricity forms obviously when there's some sort of friction occurring. When you rub a balloon on your hair and it sticks to the wall, when you shuffle your feet across the carpet and then you go and touch your younger brother or sister on the ear, that's that buildup of charge. So friction causes the extra charge to build up. Now your body doesn't want to have a charge. Objects don't want to have charges to them. And we're going to find this out with a cloud as well in a few minutes here. So when you have an excess of negative charges build up on you, you want to get rid of them, and that's why you zap your little brother, or you touch the piece of metal, and that discharge or the zap is that are those extra electrons that are leaving your body. Also talked about in section 1, conductors and insulators. Conductors you're going to find are very dense materials. Think of things that are great conductors. Metals, they're very dense. Their particles are very close together, and it allows the electrons to pass through them, and it will conduct electricity. Whereas insulators are things that are not very dense. Rubber, plastic, things that are very low density, meaning their molecules are very spread out, and they don't allow those electrons to pass through them. So they are good at preventing you from getting shocked. The big one I want to talk about today is lightning, and it's kind of hard to draw a picture of this, so I found a website that talks about lightning here. Essentially, lightning is just a huge example of static electricity. So what happens as the rain is falling down in the clouds and there are updrafts because of the low pressure centers, whenever there's a storm, that friction causes a charge separation in the clouds. You can see the positive charges separate to the top of the cloud, the negative charges separate to the bottom of the cloud. Just like you, when you shuffle across the carpet, the cloud does not want to be charged, so it's trying to find a way to get rid of that charge, and there are three ways to do that. Sometimes you'll see the lightning go from the bottom of the cloud to the top of the cloud. That's intra-cloud lightning. That happens quite a bit. Sometimes you see cloud-to-cloud lightning. Again, that happens quite a bit. The least frequent of these is cloud to ground, but that's the one we're obviously the most concerned about. So that's what I want to talk about here. So if you look at the picture, we have these negative charges at the bottom. We said the cloud does not want to be negatively charged. So as it gets closer to the ground, there are all of these objects on the ground that have both positive and negative charges, but they'll start to separate because opposites attract. We went over that last section. So what happens is the positive charges move to the top, and a step leader are these little, it's not the actual lightning strike. It's very rare to see this on film, but these electrons will make a path down to usually the highest or tallest object, which is why you don't want to be out in the middle of an open field during a lightning storm. And once that connection is made, then the return stroke is the actual lightning. Now, sometimes there's such a great charge buildup, just one lightning strike doesn't get rid of all the charge. So now there's already a connection there. It may flash 2, 3, 4 times before it can get rid of all that excess charge in a lightning strike. How do lightning rods work? Well, essentially what they are doing, they're trying to attract the lightning and then safely ground into the ground so it's not going to blow up a building or hit a tree or harm anyone. So hopefully that helps you out a little bit with lightning. Your assignment for today is to answer the section review questions on page 597. We'll go over those tomorrow. And then we are also going to move into section 3. I'm going to have you guys read 21.3 and define those vocabulary terms. And I'll put all that information on the assignment for you as well. You don't have to memorize it from the video. Again, if you have questions, send me an email. I'll be happy to answer those for you. Have a great day.